This is a dysentery. It works on an excess parallel split criteria. It divides the data in uh, two parts in different parts, different parts till the time we have till the time we have concrete rules as the output. Okay. So what we do here is what we do here is it uses techniques called uh, entropy and information gain on the cycle. Okay. So I'll not explain this thing how this works. I'll just explain a bit of the theory to you, like this only. So till now, anybody any doubts till now?
Hello, sir.
Yeah,
Sir, decision tree will automatically split until he gets a perfect match or perfect
yeah,
group.
yeah. So the thing is, it keeps on splitting the data basis various parameters like the actors and the budget. It will see which of the how many groups needs to be formed. There's certain tuning which we can do, which we will discuss once I do the practical. But so it's a way like how it works. How we do it is the things that there are certain things that are in our hand as well. So we can prune the decision trees. When we say prune is cutting the decision in case the decision trees are going very in a very lower stage, which we don't want to execute. So what we do, we prune the decision tree. We ask the decision tree to not to go into that detail. Just give me one or two level of decisions. So right now the hyperplane, which I will present it, is a plane. Access is y axis. In case we have various variables, actors, budget, their age, their like are they belong to some of the actor family only, and we have n number of things. So it will keep on dividing these n-dimensional planes, but it will divide basis the criteria entropy and information gain. So I'll not go deeper into the mathematics. The formula of entropy, is minus p log 2p. So I'll not go deeper into that. So that is the criteria to split the data.
Sir, decision tree comes in part of clustering.
No. So let's example we the dependent variable in our scenario is uh, uh, budget.
Okay.
Oh sorry, actors. We have a budget and we want to finalize like whether we can go with the A plus sector or A minus sector. So what we do is budget is a independent variable and actor is a dependent, or I'll take a vice versa. Actor is a dependent or budget is a actor is independent and budget is a dependent variable. So whatever scenario we'll take, it will be basis that consideration only.
Okay, sir.
Anybody, any other doubt?
So when will your session will get uploaded on YouTube?
So this one,
Yeah, yesterday and this one also.
so like somebody from um, like the like some counselor, that the counselor will be able to communicate it to you.
Okay, sir.
Sir, hello, sir.
Yeah.
So yesterday in the algorithm, you talked about the error part,
Mhm.
but we haven't added the error in this model.
So error is not a thing that needs to be added. The thing is, like it is a thing like which I've been showing yesterday, like the error thing that can be added and all other things. So whenever we give the prediction, so right now the mean absolute error is what, like the, okay, just give me a second. So it is coming 3.95. So it means whatever value you are giving as a output, it can increase or decrease by the value of 3.95. Is the thing that you can give along with the prediction when you are when you are giving.
So which absolute value range is good? You said zero is not the accurate, or it will overlap or overfit.
So the thing is, what was the data? This was the data. So if I'll say this 25. So whenever I'll say this predicted value, so I'll give the output that whatever my predicted value will be, every value has to be added or deducted by 3.95. So let's say example 4. I'll say the predicted value is, it ranges between is equal to this plus 4, then absolute error we have, or is equal to this minus 4. The value will range between 21 to 29.
Okay.
So this is the thing which I'll give. So
Okay.
it is going to 33, but at least 29 is more closer. So it was 27. It was 27. Value we have
Yes, sir.
predicted is 29. So it was not falling near to this range, but if we'll give this range, this value has a higher chances that this value will fall in this range only.
Okay, sir.
Anybody, any other doubt till now? So decision tree, I'll explain again. So decision tree is a, so decision tree is basically a an algorithm which works on axis parallel split. It keeps on splitting the data till the time the dependent variable is being predicted with a certain accuracy. The way that we have been seeing, it keeps on splitting the actors and any other thing like in our scenario can be till the time the output variable is being reached with a certain level of accuracy. So it uses two criteria on the back end. One is entropy and second is information gain on the back end to do this access parallel splitting. So if you want, I'll tell you a bit more about entropy and uh, information gain. So entropy is nothing. So entropy is basically used to calculate the split in the information gain. This is known as entropy. So entropy is calculated um, like for this decision trees with a formula called minus p log 2 of p. So I'll not go deep into that. So just get on the understanding of this only, and we'll go into the coding part where we will learn how the decision tree will work. Like I'll show some of the things theoretically as well and some of the things practically as well. So I'll give an example. I'll say how the decision tree will work. I'll say control N. I'll say I have the variables. Okay, I'll take this data. So like, let's say this is the data. The thing that I've been trying to predict is rainfall, whether it is a rainfall. Okay, first of all, the decision tree decision trees can be used for classification or regression. These can be used for classification or regression problem. The problem that I have is a regression classification problem. I need to classify. It's a binomial kind of a data. No and yes, only two outcomes are there. So how decision tree will work? Decision tree will see which of the variable, which of the variable output. So it will plot in a multiple dimensional hyperplane, and it will see when the location is. So what is the location here? Only Albury. So if the location is an only Albury, so this particular variable is not important in deciding anything. Okay. So it will say now minimum temperature, it ranges from -2 to 28. So it will make a group out of it, and it will see in which of the group, which of the other value is falling, and what nodes it can make. It will make a node bucket from -2 to -2 to +2, +2 to +4. In a similar way, it will make a nodes of the other variables as well, and it will see when it is window, this variable wind dir 9 a.m. 9 like wind direction at 9 a.m. If it is east, if it is east, then the temperature ranges from -1.3 to 20, and along with it, if the wind direction at 3 p.m. is again east, then maximum temperature is 15 degrees. So these kind of nodes or these kind of axis, it will make axis parallel split kind of a thing, it will make on the backend. Are you guys with me? Okay. We'll end the session here only for today, and tomorrow will go a bit deeper into the decision trees theory part as well, and the practical part as well. How will we make the decision tree over the Python? And you will be getting this material from yeah. This entire material will be shared. Uh, don't worry. Don't worry. This entire material will be shared. Yeah. So this upload and the thing has been will be done by like the counselor only. Okay. Thank you very much, guys. Uh, we'll meet tomorrow at 9. Okay, not at 8:45. We'll meet tomorrow at 9. Thank you. Bye, everybody.